Hey everyone, this is Sage with Orca Design and Manufacturing, and today's video is about the setup and use of Barnie. First step in this process is basically connecting to your DSP. In this video, we're using a Pico 8-10 DSP. So we'll open our software and click on Pico 8-10 DSP and click Connect Device. Okay, so we're going to connect to the 8-10 DSP, and then a menu pops up. We're going to click Read Single Preset, get connected to the DSP. And now that we're connected, we are going to connect Barnie to the software. So to do so, you'll hit the Measure tab, and it opens up the Measure window in the software. If you're using the MOS mic, you're going to want to make sure that you hit Connect Mic before you plug the MOS mic into the amplifier or DSP. So we'll hit Connect Mic. And what Connect Mic does is it makes sure that the mixer is all zeros, so there's no sound coming in or going out of the processor. If you don't hit Connect Mic and plug this into the MOS mic into the DSP, you can get microphone feedback and blow up speakers in the car. So it's very important that you hit the Connect Mic button before plugging in the MOS mic. Now we got everything connected. That you want to do before taking any measurements, set high pass crossovers on especially the tweeters and sometimes mid-range drivers or mid-bass drivers to protect them, because when we're taking measurements, we're playing sine sweeps from 20 to 20K, and you want to make sure that you cross over the speakers. Go into your crossover filter section and make sure you do have a high pass on the tweeters. And we'll go ahead and put a high pass on the mid-bass drivers. We don't need to do any type of crossover on the subwoofer right now. That'll be fine. The first step in doing the whole setup is taking your delay measurements. You'll click on the delay tab, and you see you have your green boxes to the left. You have channel 1, 2, 5, and 6, which is actually our 1 and 2 are our tweeters, 5 and 6 are our mid-bass drivers, and they correlate to these windows here. So this is your front left tweeter, this is your front right tweeter, left mid-bass, right mid-bass. To take a measurement, you just basically click on the measure tab, and you get a reading, and you click it again and it stops. You go to your next speaker, get the reading and press the button so it stops, and move on to your next speaker. Once you get the time delay measurements for the tweeters and mids, you will have to use a measuring tape to measure from the subwoofer to the Barnie head. The direct pulses that the software plays, the subwoofer is not able to play those frequencies, so it can't pick up the distance of the subwoofer. So we're probably 30 inches from the subwoofer. Type in 30 and 30. You guys see on the screen, we have distances, we have some delay in milliseconds, and then we have where it says phase gain. You notice the left channels are negative 1.5 and the right channels are negative 1. Reason being is the left speakers are closer to Barnie, so it automatically calculates and turns them down a little bit to make sure they're at the same volume level. Once you get all this stuff, you want to make sure you also send delay. You can also send gain. You see where it says normal right here on the screen? If that's red and it says invert, you want to send phase. It's basically checking the speaker to see if it's in or out of phase. In this case, it's not, so we don't need to send any type of phase information. At this point, we can just send done reset. We go back here, and now you guys can see that we have our delay populated on those channels. Left tweeter, right tweeter, left mid-bass, right mid-bass. And it automatically adjusted levels for us. So at this point, we're gonna check the frequency response of each speaker and put them amongst our target curve. What I do is I'll start with the mid-bass drivers. You have signal generator and measure level. So basically this is your microphone sensitivity. I'm gonna put that at 0 dB. I don't want that boosted because I don't want to pick up any type of noise in the background. And then I'm going to set the signal generator level to negative 25. That's my recommended settings for most situations. At this point, we can hit the RTA button. And now we can see the frequency response of the mid-bass drivers without a low pass on them. So they're just crossed over at 80 Hertz high pass, and they're playing up as high as they possibly can. So these drivers seem to play all the way up to 5,800, 6,000. What I'll do at this point is go into my tweeter, change my crossover. Let's start at 5,000 Hertz. Go back to the measure screen, turn on our tweeters, and run And now we can see over here that they're actually crossing over at 6,000 hertz. The objective of the game here, you see this curve here, which I can turn it on and off in the software. That's our reference curve. At the end of the whole process here, we're going to EQ them and set them up to match this line. We want to adjust levels to start with to make sure that our speakers are matched amongst the target curve line. We can turn up and down the tweeters, and we can turn up and down the mid-bass drivers. So I'll just run this again and start working on that. The mid-bass is playing all the way out as far as it can, so I'm going to put a 3500 hertz low pass on the mid-bass driver and go ahead and run that again. I can run my tweeter again. Basically what I'm trying to do here, I want to adjust the tweeter level and I want to adjust the mid level so it's amongst the target curve, because I don't want to pull down all these frequencies to this line. I want to do the least amount of equalization possible. So getting your levels of your tweeters and your mid-bass and your mid-range drivers amongst the target curve to start with, you'll end up with better results right out of the gate. I'm going to go ahead and turn down the tweeters, change these. Turn the tweeters down, then I'll run the tweeters again. Okay. Now I'm going to run the mid-bass. The crossover point right now is at 4,300 hertz. So if I turn down the mid-bass driver, it's actually going to move this crossover point down and get it closer to the 3,500 hertz crossover point. So I'm going to go back to my levels and turn down. Turn that down 6 dB. Go ahead and run that again. All right, so now we're closer to our target frequency of 3,500 hertz. We're gonna go ahead and move to phase. So in phase, when you hit the phase tab, the first thing that pops up that you'll see at the top of the screen, it says choose reference channels not shifted. What that means is when you're phase aligning the front stage, the channel not shifted is the driver that's playing the largest bandwidth. It's a 6.5 inch and tweeter two-way. The driver not shifted would be the 6.5. If it's a three-way system with a 6.5 mid-bass, a 3-inch mid-range, and a tweeter, your reference driver that's not shifted will be your mid-range driver, because that driver is playing the largest bandwidth. Since it says choose reference channel not shifted, we're going to choose channel 5 and 6 and hit OK measure. And now it says choose channel 2 phase adjust. That'll be the tweeters. You guys can see right here, it says 3759 is the crossover point. That's close enough to our target crossover point. In the software, you guys see fast, fine, and precision. Normally, you're gonna wanna just use fine. It's a good phase shifts, and it'll give you really close to a target phase response. Press start. It's changing phase 40 degrees at a time. In your phase C box, you see its final phase shift. It says 0 degrees. Let's go back and check. It actually didn't do any type of phase adjustment at all. So I guess I got them lined up very well. So sometimes that happens. There's no phase adjust between the two. Normally, if it does a phase adjust, it's going to put an all-pass filter here in these last boxes of the tweeters, but in this case, it didn't do any type of phase adjust. At this point, we can run the full response. This is the response of our 6.5 inch tweeters with no EQ. We're going to move on to equalization of the front speakers. You can press this auto adjust reference curve which will split the energy on top and below the reference curve line. Sometimes I don't do that. I don't want to try to boost all this low end frequency and boost all this high end frequency. So what I'm going to do is I'm going to actually turn down my reference curve so I have less boost on the top end, and I'm going to pull all this stuff down in the middle to get a better sound without boosting a bunch of stuff. And then we can also see that the response of this system starts rolling off pretty bad at 240 hertz down. So we're not going to actually be able to boost this up a lot in this particular situation. So I'll probably choose to just EQ from 200 to 20K. We'll come out of here, we'll go into the equalizer for the front. And over here on the right hand side it says auto adjust. Enter our range, 200 to 20K, and then we're going to do left right sum. So what that left right sum means is it EQs the left, then it EQs the right, and then it EQs the left and right together. Another thing that you want to check, the advanced settings. You can adjust your max boost. I'm not allowing the equalizer to boost more than 3 dB. You can put this at 0 dB, you can put it at 6 dB, you can put it at 12 dB. Recommend default at 3 dB. You don't really want to boost more than that. So all this stuff will be pre-populated. You just want to make sure you click left right sum, 3 dB boost, and you basically press start. That's our front stage frequency response after the auto EQ. Now we have the front stage done, and now I'm going to go ahead and add the subwoofer into this. Looks like we're going to want our subwoofer to kind of play up high to meet up with this front stage, because this front stage does not play very low. Let's turn on our sub, play the sub up high. You guys see this mouse position? So I can move this mouse around on the screen and it tells me what frequency I'm at. Hopefully I can blend the sub in a little bit high. I want it to at least play up to 125, 150 hertz. So we'll go over here to the subwoofer, do a crossover slope of 125. Put it to 18 dB Butterworth and hit RTA. We need to make some adjustments to the level. You guys see me clicking on these letter boxes next to the speakers. You can actually use these to adjust levels together. I'm gonna go ahead and turn the sub down. I'll go ahead and turn it down to 3. Run the subwoofer. Definitely have some type of something going on in this particular demonstration with a big dip, but once we try to fix the phase and do some EQ, we can probably get rid of this dip. So let's just go ahead and move into phase. Back at the phase shift, choose channels not shifted, which are gonna go back to the 6.5 inch mid basses in this particular situation, because there's basically no phase adjustment to those drivers. The tweeters are phase aligned to the mid basses, and then we're gonna phase align the subwoofers to the mid basses and run the frequency. And now we can run the frequency response of the subwoofer. And we're at 139 hertz. We'll go ahead and press start. You guys can see right here the final phase shift on the sub was 125 degrees. We can go and look at the sub, and it added a 72 hertz first order all pass to the subwoofer to fix the phase at the crossover point. And run our full frequency response. We added the subwoofer to the front stage. Obviously you guys can see it's not a perfect frequency response. It's just the nature of the room that we're dealing with. In a vehicle, you 99.9% of the time will get a really nice flat frequency response that matches your target curve completely. In this particular situation, demo situation, we're not in the perfect environment for this, but I just wanted to show you guys the basic steps on how to use the software with Barnie. You're technically done tuning the vehicle. Next step, disconnecting the microphone from the vehicle and then listening to the car. Hit the connect mic button again. We can go ahead and unplug Barnie from the amplifier. Good, that's unplugged. Okay, you're going to want to make some adjustments to the audio system. You're going to want to adjust things all together. If you're going to want to turn up the front stage, you're going to want to select tweeters and mid basses together, and then you can turn them up together. You can turn them down together to your desired listening level. If you want to move the center image left to right in the car, you would change these boxes and you would do the left side as A and the right side as B. If you need to move the image to the right or left, you can use the left side and adjust the levels up and down to steer the image to the center of the vehicle. You don't want to go back in and change time delay, because once you change that, it's going to change the phase response and all that stuff. And then obviously you can adjust your sub level. In normal listening, you're going to want your sub a lot higher than what it shows on the graph. And at this point, you're basically done tuning the car. You can get in it and turn on the music, and I promise you it'll sound great. All right, so now we're going to talk about the Rode AI USB microphone preamp. You'll use this if you don't have a BT Plus port on your processor, like an old 6 to 8 aerospace or older 8 to 12 aerospace. This is not really used very often in newer product, but if you have an older product, this is how you use this. The only difference between this and the Moss mic is the way it does time delay. So I'm going to show you guys really quick how it does time delay. First things first, we're going to go ahead and minimize the software, and we're going to find the Rode Central app, which you need to download to your computer. All right, so once you open the app, the Rode Central app, you can plug in the Rode AI module into the USB of the computer. Click on your AI micro. You get this window that pops up. On the Rode AI, there's 2 inputs on it, or 3 inputs. There's a stereo 1 headphone and stereo 2. So you're going to use stereo 1 input. Make sure on your app, you guys can see, you can click on this and change this. You want to put this on stereo 1. You want to go here to stereo 1, and you're going to want to turn this level all the way up max. So once you get that setting done, you can go ahead and minimize the app. You do not want to close the app, because if you close the app, the Rode AI will disconnect from the computer. You can go back into your software, go into measure, click on USB sound card, and then we're going to go to the delay tab, and I'm going to show you how to do the delay. Turn on all the speakers except the subwoofer, because the direct pulses cannot be played by the sub, so we're still going to have to enter those manually by measuring with a tape measure. Right now I have my front tweeters and my front mid basses on, and I'm going to go ahead and turn up my mic sensitivity. Press delay. With the Rode, you don't click on each individual speaker, it does it all together in one process. Press start. Everything's good. Press OK, go on. And now you have all your values. Enter the distance of the subwoofer. Once we get all these measurements, you have 3 options to send to the DSP. We have delay, we have gain, and we have phase. As you guys can see here, it's saying that the tweeters are inverted, and we have some level differences. So the tweeters are at -0.5, the mid basses are at 0, and the subs are at -0.5. Send all this information by clicking these 3 check boxes. So we'll hit calc values and send to DSP, and then done reset, and go over here, and it populates the delay levels, and it also changed the phase of the tweeters automatically for us. Everything else with the Rode AI, the works exactly the same. Thank you for watching.